Let's look at question number 11, part A of the applied paper, which is the velocity time curve question. Right. So a car P starts from rest at point O at time 0 seconds, moves with constant acceleration if it accelerates uniformly until t equals capital T, then continues with the constant speed it gains. Another car Q starts from rest at the same point O at time t equals t plus 2 seconds and moves with same constant acceleration if Q maintains this acceleration for 3t over 2 seconds, then continues with constant speed it gains. Both cars move in the same direction on the same horizontal road. Sketch velocity time graph for motions of P and Q in the same diagram. Right. So first we'll do that. Right. So P starts from rest, accelerates for capital T seconds, then maintains that speed. Right. Then Q starts from rest from T plus 2 seconds and goes with same acceleration and maintains that for 3t and a half. So these times are what? Now use the, this is what, f acceleration up to this speed, which takes capital T time. So this time also should be what? It should take capital T time to reach zero. Sorry, you this speed. This also starts from zero, same acceleration. So this time should be 2t plus 2. That is from here because this takes t seconds. No? So then this should also take t seconds. It follows the same acceleration, starts with same speed. Right. Then this time is what? T plus 3t over 2. So which is 5t, no, t plus 2, no, t plus 2 plus. So 5t over 2 plus 2. Right. Right. Then it goes with same speed, same constant speed. Right. So let's mark this as u and this as v. We'll use a different color for this. So this is q, this is p. Right. And these gradients are the same acceleration, or tan theta is f. Right. So the sketch is done. Then find the distance between cars P and Q in terms of simple F and capital T when their velocities are equal. When their velocities are equal. So let me label them OA, B, C, D. Right. So distance. So let's go. So we need this speed in terms of f and t. So we can use OAE triangle. Use OAE triangle. So tan theta is f, no? So f is equal to u over capital T. So u is equal to ft, right? So we know u is ft, right? So then distance travel by p until the velocities match is what? Half into u into the two parallel lengths. So those are AB length and OC length. AB is 2t plus 2 minus 2. 2t plus 2. AB is this length minus t. So 2t plus 2 minus t, which is t plus 2. T plus 2 plus 2t plus 2, which is the OC length. So half u is ft 3t plus 4, right? So this is distance traveled by p, then distance traveled by q is what? That is given by BCD triangle, half u into t, half u into t. This base length is t, no? So therefore half u into t. U is ft we found. So half ft square, right? So distance between these two are distance between p and q is what? Half ft 3t plus 4 minus half ft square. We'll take half ft out. So 3t plus 4 minus t, half ft 2t plus 4. Then we can cancel a 2 with the half ft t plus 2. Right, that is the distance between p and q when the speeds match, when the velocities match. Right. So that part is done. Show that q cannot overtake p until q gains its maximum speed. Q gains its maximum. Show that q cannot overtake. So right. So let's look at this O A B C D E F H. You can look at DFH triangle and find V, maximum speed of the Q. So that is F over, sorry, F, the gradient F is equal to V over 3t over 2. So V is equal to 3ft over 2, right? So this is 3ft over 2, right? Okay, now let's see. So now this part, me FH, BCIH part, both have the same distance. No. So in this section, the additional distance that the Q car travels is BFI, right? Until it reaches maximum speed, the additional distance that the car Q travels is BFI, no? Right? We have to show that that is less than the distance between the two cars when the speeds were same. So this is the distance between the two cars when the speeds match. After the speeds match, BCIH is the distance traveled by P, and that distance is also traveled by Q, and additional this part is gone by Q. This is the additional distance gone until Q reaches its maximum speed. So that additional distance will find additional distance traveled by Q until it reaches max speed is what? Half half base is T over 2. So BFI triangle. So let me write that. That is given by BFI triangle. So half T over 2 is the base. Height is what? Height is V minus U. 3ft over 2 minus ft over 2. Ft over 2. So ft squared over 8. Right, this is the additional distance traveled by car Q after it reaches the same speed as P until Q reaches its maximum speed. Right, now we need to show that it can't overtake until it reaches max speed. So it has to overcome what? This amount to overtake it. No? Overtake the To overtake, it has to overcome this amount, the distance between P and Q when the speeds match. So we take the difference. If the difference is positive, additional distance will subtract. If we can show that this distance is positive, then Q has not overtaken P. So Ft squared plus 2Ft minus Ft squared over 8. So let's say D is the distance between the two cars. We need to show this is positive. 7Ft squared over 8 plus 2Ft. Right, this is positive. No, time is positive. Acceleration is positive. Right. So then we can say distance is positive. Therefore, Q has not overtaken P. So part 2 is done. Now last part. So still there's this distance between the two cars. Okay, P and Q. Right, then show that Q overtakes P at simple at this time. So Now we'll focus on only this section. Let's take this time from here onwards to be t1. So once both cars travel additional t1, let's assume that q catches up to p. So then in this section, so in this t1 time period, p travels what? U into t1 distance, q travels v into t1 distance. So this, if q catches p, then q travel distance v into t1 should be equal to u into t1 plus this distance. Then p catches q, sorry, q catches p. So q travels how much distance? V into t1. That has to be equal to u into t1 plus the distance between between these two cars up to phi t, that time period, up to this time period, up to this time period. So that amount 7 ft squared over 8 plus 2 ft. So this amount has to match the distance it had to cover plus the distance traveled by car p during t1 time period, which is ut1. So v is what? 3 ft over 2 t1. This is ft over t1. 7 ft squared over 8 plus 2 ft. So now simplify and find t1. So you can cancel ft, 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 ft. So write what is left. 3 over 2 t1, t1 plus 7 over 8t plus 2. So move t1 to this side, half t1, 7 over 8t, 7 over 8t plus 2 multiply by t 2, 7 over 4t plus 4. So that is the t1 period that q has to travel to catch up to p. So then the total time is what? Until q catch up to p is what? Total time is this amount plus t1, 5t over 2, 5t over 2 plus 2 plus t1. So 5t over 2 plus 2, 7t over 4 plus 4. So simplify 4, 17t plus 24. Right, that's what we want to show. Right, so that amount of seconds it takes q to overtake p at that time. So right, so we have shown that. So next we'll look at the part b of this question.